Hi guys, today we are going to talk about the common drain amplifier, most popularly known as source follower. This is a single stage amplifier, and in this configuration the input is given to the gate terminal and the output is taken out of the source terminal while the drain terminal is held at a common potential, hence the name common drain amplifier. The source follower is a very useful CMOS design due to its low output impedance and high input impedance. We will derive the input resistance, output resistance and the gain of this amplifier. This is enough to understand the characteristics of this single stage amplifier. First, let's find the input resistance of this. So I have drawn the small signal model and we need to make small changes to this. So in order to find the input resistance, we need to give a test voltage, V test, to the input. So I am giving a test voltage here. This produces a test current. And let's see how this looks in a small signal model. So my test voltage will be given here. And I've grounded the drain terminal because the drain terminal is connected to VDD, which would be AC ground in the small signal model. And here the Rin would be the input resistance is equal to V test divided by I test. And you can see there is no path for the current to flow. So essentially I test is equal to 0. So Rin is equal to infinity. So the input resistance of a source follower is infinite. Now let's try to find the gain of the amplifier. I have drawn the small signal model, and first let's find out what V out is here. We need to know what is the current in order to find the V out. The current in this branch is just GM/VGS. So by performing Ohm's law, we just know GM/VGS, which is the current, into resistance is the voltage. And VGS is equal to the gate voltage minus the source voltage. Here the gate voltage is V in and the source voltage is V out. By substituting all of this, we get V out is equal to GM V in minus V out into RS. So V out is equal to 1 plus GMRS equal to V in GMRS. So V out by V in, which is the gain, can be given as GMRS divided by 1 plus GMRS. Now to find the output resistance, you ground the input and you give a test voltage at the output. So you ground the input and let me change the color. You give a test voltage, V test, which has a test current, I test. Now let's try to perform KCL at this node. So there is a branch over here, current flows like this. So this is how our KCL will look like. So let's write the equation for this. I test plus GM VGS is equal to V out divided by RS. The current through this resistor would be, sorry, my bad, it is actually V test divided by RS. And we know VGS is VG minus VS. So let's try to rewrite VGS. The gate is grounded, so 0 minus V out. Again, it's not V out, it is 0 minus V test. And the output resistance R out is given as V test by I test. So let's try to break down this equation. So I test is the minus GM V test is equal to V test divided by RS. Test is equal to V test GM plus 1 by RS. Thus, the output resistance is given as RS divided by 1 plus GM RS. And these are the three important equations that is needed to understand the basic characteristics of a source follower. Thank you so much for watching and see you guys in the next video. Bye.